morning, I'm Jerry Peterson. Today we're going to talk about emerging technologies, and what we're inferring with that is that these are technologies that are available, but maybe we don't have the uptake that we want. Maybe they're just not out there in circulation. And so as things are introduced and they move their way up the market, we tend to kind of classify those as emerging. So if you're wondering about the title, that's kind of how we got that. So big thanks to NIA for their support, Damon and Dylan here at Integrated Design Lab, and every one of you for taking your time to come to today's presentation. I know your time is valuable, and I'll try to be respectful of that. This is me. I work in this arena, in the energy efficiency arena. I do a lot of stuff with residential, and I'm not just a presenter. I actually own a business, and so a lot of my presentations are based on work that I've been involved in or work that I'm doing. And so I'm not afraid to go in crawl spaces or attic. This is earlier this year. The stick is for bugs that don't want to leave. I just don't like things right in my face, but yeah, it's interesting, and I want to bring that perspective to the presentations. I want people to know I'm not asking you to do something that I wouldn't or couldn't do myself. So, we're going through different portions of residential training. Just understand that I'm familiar with this, and I do this kind of work. So I've got, I borrowed some slides from a previous NIA presentation. The companies that were participating in that were A.O. Smith, Ream, and those are just some of the companies that provide these products. And so as I go through there, just know that this is kind of where that information. I also did a little bit of local search. I wanted to get some current pricing, some Energy Star use comparisons, and then what was available from wholesalers. So we'll cover that a little bit later. So goals for today's trainings is we want to talk about installing these in small spaces. I think one of the obstacles or difficulties with these are actually the location where we're putting them, how they have to be installed. They do make condensate, and so we have to provide for that. And then how do we size them? And then they're different operational modes. I'm not going to cover error codes. I should change that. So this is an example, Bradford White. The big thing with all of this is, and the reason I'm not showing you all the variations, is they're all very similar. They're all designed to go in fairly restricted spaces. And in most cases, if you're doing this in an existing house, it will fit in the space that your current water heater is in, with a few exceptions. So they don't need a lot of space. We'll talk about airflow and things like that, but the water heater itself, it doesn't have to have a lot of access. So in looking at all of the different brands, the spacing is going to be very, very similar. Sometimes they turn them, to clear different things. They do fit in fairly small spaces. Because it is a heat pump, it needs a volume of air to work with. You're pulling heat out of the air, and it has to have some volume to do that. And so if you're doing it in a room that's fairly open, it doesn't have to be that big. They're saying, approximately 700 cubic feet, not square feet, cubic feet, which is not a large room. We can talk about a little bit about garage installations and stuff, but as we're going through this, kind of keep in mind that the warmer the space is in, the more efficient the unit is. And so if we stick it outside in the shed, we're great in the summertime, but probably not so good in the wintertime. So we want to, that's part of the location. So we have the clearance issue, but then we have the space where it's going to be located. It is possible to add venting. We'll cover that in a minute. If you are putting it in an existing closet, a utility closet, it would need to have louvers on the door to allow for adequate airflow. And if for all of you that have attended my attic ventilation courses, you're familiar with this net-free area, this NFA. Most standalone louvers, this will be stamped on the louver itself or on the box that it comes in. If not, you measure the rough opening, which you can take the total area, but this would be more accurate. Would be to measure the inside of it and then times that by 0.7, and that would give you a pretty rough idea of what the actual opening size is. Again, you would want, kind of air more towards more than less. And so if you don't have a louvered door, you can obviously, depending on the construction of the door, you can add louvers to the door. And or if sometimes these spaces are bigger inside, you have a door, but you walk in there and it's bigger, you could put the louvers on the wall, high and low on the wall, or around the corner, or some way to get some air to move through there. If you are doing ducting to it, say the room is you don't want louvers to it, for a variety of reasons, you don't want louvers in there, you can pull ducting into it. You can duct right to the unit itself, and each of the different brands will have their own specifications as to what size the duct needs to be, how long the run can be. But it is possible to run ducting in and out of them. To use them in a smaller space, but the clearances will change on it. So just be aware of that. They're, to allow room to hook the ducting up to it and still be able to service the top of it. So I think on this particular one, without the ducting, you need 8 inches clearance above it. With the ducting, you need 17. So just be aware that if you're ducting to it, then you're going to need a little more space. And then this gives you your duct runs. I have some other pictures of different types of wall caps, but it will talk about duct size, how far to go, with elbows. This is not restrictive. This would be really, really easy to do. So how do we know, if we have enough space or if we need ducting? Basically, we just pay attention to the area that it's in. If we put it in a small room in the basement or something, and the temperature, it's pulling that temperature down below 15 degrees in that room, you don't have enough space. It's too cold. And so typically, it will drop the temperature of that space 3 to 5 degrees. So kind of knowing this up front, if you're designing a building, a house, and you're looking at potentially looking at installing one of these, instead of this being a negative, turn it to a positive. And it's like, well, if you have air in a room that is excessively hot, solar gain upstairs, for some reason, you have, trapped heat or unwanted heat up there, that would be a great place to pull this from. And so using it to your advantage, and have some graphs at the end that shows how basically you can get free heat to run these. But yeah, again, this presentation is geared kind of towards architects and engineers. It's like use nature. Don't put it in a cold room if you have access to a warmer space. Condensation is a real thing. And so we want to be careful that that we're insulating the ducts, that we're not just leaving this single wrap exposed. We're transferring heat and cold and it will condense. So make sure that as much as possible that we're, bringing the insulation down over the connections and making sure the foil is intact and stuff so that we're not making unwanted water dripping into the space. As far as hooking up flex duct to this, it's the same approach, same codes that we would use for HVAC. And so this doesn't require some different process. It's not under a lot of pressure. And so, we don't have to use tape, but typically that's how we do it. We tape the inner liner. We'll slide this over the connections. We'll tape this joint and it has to be a UL listed tape and it'll have an FX donation on it, or which says flex basically. So there's a special tape that we use on that. So we'll tape that first layer, pull the insulation over it, and then use a conduit, to secure the bigger part of it. And that's how we install almost all residential HVAC systems. So we don't have to worry about it coming loose over time, and it will be tight. So if you are pulling from another space, say, you have a utility closet and you want to pull the air from another room, or it's located out in the garage, but shouldn't say that because you can't transfer between the garage and living space. I'll clarify that. So you want to pull it from another room, you don't have enough physical space in there, or you have a room that is typically warm, you want to remove some heat from, you can duct into that. And they make these kits, all of the different manufacturers have wall kits. And so you could pull from one room, up here and duct it down to the water heater instead of trying to pull from the space. So that is an option if you need it. And it doesn't look, intrusive. So. And the 6-inch, again, it depends on the manufacturers and the size of it. It could be an 8. So this is kind of what they look like. A typical water heater would not have the coil assembly in it. You just have the two elements in there. And so the way water heaters work, you have a cold pipe coming down to the bottom. And as you use the water, heat rises. So it flows out the top and then the incoming water goes to the bottom. There's no magic to it. That's kind of how it works. The water, it doesn't have a mixing effect. And so the cold water kind of stays to the bottom. And in a typical water heater, once this element senses cold water, it will come on. And as you keep using it, and then this one senses cold water, then it will come on and both of them will run at the same time. So if you're actually running out of hot water, it's going to use both of the, use the elements in that order. So what this does is it's coming down, with heat and putting it in there and warming it up. So this works great. It's the same principle as an air conditioner. It's just putting the heat into the lines instead of running it through a coil or just lost for words this morning. Running it through the air handler and run it through a coil assembly. This is just a different approach to it. So if everything is working right and you're not using excessive amounts of hot water, the pump will take care of all of it and it will run all of it. And so, I'll show you how, array water heaters and stuff, but that's the intent, is to let this run, keep all of this warm. You have all the hot water you need. Until, like I said, if you have 3 people taking showers back to back, it's probably going to engage the elements at some point. But there's just a note on here I left. It says that, condensate is not produced when incoming air is below 36. Obviously, we want this to be in a warmer location. If we're running this in a 36-degree room, we're probably, it's not going to be super efficient. So we do, in the Treasure Valley, we do run a lot of our equipment in the garages. And so if a lot of new houses, the garage is insulated. My house is insulated. It has an insulated door on it. And even in the winter time, it will stay above 50 degrees out there with no heat. That wouldn't be ideal, but it would work. I mean, that's not a bad place for it. And the garage is huge, and so it wouldn't affect, if it cooled it off in there a couple of degrees, you wouldn't even notice it. So kind of depends on thinking that through in the placement part of it. If you're putting in a garage, is the garage insulated, is open, is it even reasonably sealed? Because if it's not, I have another house I'm working on. We monitored garage temps before we did the remodel on it. And in the winter time, it would actually freeze in there. I was always amazed the water heater didn't freeze and break the pipes, but it would freeze. You'd bring your car in there with ice on it, it wouldn't do anything. We've insulated the garage, put a new door on it. Now it stays in the 50s. So without any additional heat. The condensate drain is pretty typical. It's going to be very similar to, if you have an existing water heater and you're replacing it, wherever your blow off valve is going, it's, unless it's just blowing out on the floor, is a good location. Or if you're putting it next to the furnace and the AC will already have a condensate on it. A lot of new houses, they provide a drain right into the floor, right next to the furnace, and they put it in there. And so they're trying to run it out through the foundation. And so if there is a hookup existing, then you just put it there, and you could, tie that together if needed. So if we go back to this for a second, the drain is going to be, it doesn't drain down in the pan. You can see right here, this is where the drain comes to it. And so this would just, you'd hook your piping into that. And so what it's saying is it needs to be level for it to, to get the right slope on it. And basically you can run it into anything that's existing. If you do need to run it somewhere different, there's a couple of places we don't like to see it. And if you're doing a basement installation, which is pretty typical, there's a lot of areas of the state, eastern Idaho almost is predominantly basements. And now that's usually where the mechanicals are located. So you can do a basement install, but you'll need to run a condensate pump on it. And again, this is the same pump, same style, same codes and everything that we would use on an air conditioner. So it's not something that people would not be familiar with. You just tell them it has to have a condensate pump and they would run it. So, and a standard pump, nothing excessive. This is pretty standard stuff and not horribly expensive. So you can't gravity drain it, and then we use condensate pumps. If you are doing, when you're hooking up that drain, be sure not to use an elbow on it. We need to have a way to clean it out or to check it. And so condensate drains, whether it's air conditioning or this, they tend to get a little gummy inside and they kind of gel up in there. So we need to be able to, stick a wire or blow down through there just to make sure that it's clean. And with an elbow, there's no way to do it. We don't have any way to access And so we don't want to be running a wire, trying to fish a wire up around there. Just put this little cap on there and you just unscrew it and it's wide open. So you can actually pour water down it. If you're not sure whether it's plugged or not, just pour a bottle of water down there and if it drains, it's good. If it overflows, then you got some blockage in there. Usually there is an error code on the unit, and so if the drain plugs for some reason it starts filling up the pan, it's going to warn you. This is the codes. I'm not going to read this, but it's the same codes for all condensate drains. The one thing with this, I'm not sure if it addresses that one of the slides, is when you're looking at condensing furnaces, 95% furnaces, the condensate coming off of that is different than coming off of this. This is non-acidic. It's literally distilled water. And so there's no, we don't have to worry about, you know, the water that's the condensate water itself. Please don't do this. You see, I see this a lot, and this is really standard with air conditioners. Almost every house I've been in that's built from the, up until the 90s, this is what they do. They'll just run that out through a foundation wall. And the problem is it actually runs and it sits against this foundation. Grows weeds and attracts bugs, and it's not ideal. We want to try and get that up and out of there. And so, we don't want to add to the problem. These were all done existing pre-code. So it's kind of hard to force them to change. But the problem with most houses is the indoor coil unit is actually below the floor. It's down in the house or really close to it. And there's no way to get a drain up and out of it, and they don't want to put a condensate pump in there, which would be the fix. So that ideally you would put a condensate, put a high gravity drain, a washer hookup, or washer type drain in there with a P-trap in it. So we don't want to see new construction, new design taking this approach. So this is their first hour ratings, and this isn't anything specific to the heat pump water heater. The code is kind of the same. The standards are the same. And so this is something that will be posted on the water heater itself. And it's just the gallons per hour. And there's a chart in the code that says, counts the bathrooms, counts the fixtures, and tells you what size it has to be. So this is not a guesswork. This is just going to the code or going to the chart and saying, I have 3 bathrooms, I need X amount of gallons per hour. So it's based on bedrooms and bathrooms or fixture count, and not perceived demand. This was interesting. Note that the hybrid water heaters have a higher first hour rating in certain operating modes. And so that would be, I'm assuming that would be using both the heat pump and the element at the same time. It would have a faster recovery. Again, just an assumption. This is kind of what they look like. You got, pretty standard water heater on the bottom and then the heat pump assembly on top. This is kind of where we get into the cost savings on it. If you can do all of it with the compressor, it's going to use about 1/8 of what the element runs. So this is where we really start to understand the cost effectiveness of it. So don't quote me on this, but right now, the last time I did the calculations, between electric water heaters and gas water heaters based on cost, it was about a 2.2, 2.4 difference. And so electric water heaters are a big user. This is going to be your second biggest use of electricity behind the air conditioner or the electric furnace. So this is a big user. In my house, I'm pretty fortunate to have a very efficient house. My water heater uses about 40% of my natural gas. So I tell people, I said, yeah, I pay as much to heat the hot water as I do to heat the house. And it's close. And so these are a big user, and in an all electric home, this is a big deal. We are blessed in a lot of Idaho to have really low utility rates. But when we get into certain parts of the state, we don't have that. And talking to people out of state that have been paying, 18 cents or higher, it's going to be a big deal. And so, again, areas that don't have access to natural gas, this would be a better market for these. Or in some, cases, even if they have access, they don't have it installed. Or, one of the houses I'm working on right now here in Boise is an all electric home, and this is the biggest user next to the air conditioner. So it's something we're looking at, considering. And we have a good location for it. It's a garage, semi-conditioned, warmer garage. So potentially. And again, here's just some other things to think about. When we look at, the codes and the charts and stuff, again, they're based on bedrooms. If you're trying to figure occupant load on a house, you do bedrooms plus one. We always estimate two in the primary. I'm having to correct my terminology. But also, for people that know they're using a lot of it. I mean, a senior couple is probably not going to use the amount of water as a growing family. Or if you have, a number of kids, so what kind of drives the on-demand water heater market is this kind of a situation where they know they're using lots of water and the system is not able to keep up. And so the best way to overcome that is just with storage. Heating more water. And then we add the recirculation pump into the mix. And I've been to several presentations on these, and the pump can really mess it up because you have a lot of standby loss in the pump. And so we have tried to modify the codes and stuff to, include insulation on pipes that are recirculating. But just having that pump running all the time is kind of working against what we're trying to do. If you're only putting, a certain amount of BTUs into the heating water, and then you're just running it around underneath the house for no real apparent reason, it's going to affect its efficiency. And so there are systems out there. This is called a smart plug. It has a sensor that goes into the pipe, and what it does is it senses the demand. So when you turn the hot water on, this senses it, and then you plug your condensate or your circulation pump into that, and this one is a self-learning one, or the state, And so each time you turn the hot water on, it sends a signal to this to turn the pump on, and it learns the schedule. It's kind of like the Nest thermostat. And so if you are, getting up, going to work at the same time every day, it will learn that schedule, and then it will turn the pump on before you need it. So you have instant hot water, which a lot of people like. And so circulation pumps are kind of standard now. I see them on a lot of houses, but they don't set the timers and they don't plug them in. They leave that to the homeowner. And depending on how intricate the timer is, a lot of people just plug them in. And without the timer on it, it just runs continuous. And if you put this type of a water heater on that system, it's not going to be as efficient as it could be. And so you can either, this particular sensor setup is about $150. The price ranged on it up over $250. Then the reason I didn't put brands on here was the reviews were really mixed. And so some people thought it was great. Some people was like, I don't think it's doing what it's supposed to do. But kind of reading through and condensing the comments on it, one of the things was, well, why not just use the timer? You set the timer up for when you know you're going to be using it, and just let the timer work and then turn it off. But there's just some other things that potentially affect the usage of it. We don't want to spend a lot of time and money designing something. These do have a pretty high upfront cost, and the elements and stuff are kind of a backup, kind of an assistance kind of thing. And so we can really kill the efficiency by not looking at locations and what other externals could affect its operation. So this is something worth looking at in the initial part. Are we going to use a recirculating system? How are we going to control that so that we get the results out of the water heater? Again, this is looking at the hybrid part of it. If it's running on the pump, you're drawing about 550. This is kind of talking about what I said. You've got an upper and a lower element, and so if you can run it on that, it's going to be a lot more efficient than running it on the elements. But they're there for a reason. We don't want people to run out of hot water. The other thing on these is a lot of homes that I go in and look at as part of audits, or just trying to look at the utility use on it. People do it's part of educating people, which if we're going to use these, we need to provide a little background for the tenants or the owners. A lot of times when the water heater isn't meeting their demands, what people do is they just turn it up. And so it's very common for me to go in and look at water heaters, and they are literally maxed out, and the water's so hot it would scald you. And you say, why do you have your hot water heater turned up? It's like, oh, it runs out of hot water. And so that's their correction, and doing that is going to kill the efficiency on these. So we want to pay attention to what we're setting it at and educate the homeowner tenant enough that they understand that they can kill it by overheating it. So I like to nobody has a thermometer that they're checking their water with. You should be able to hold your hand under there, not forever, but you should be able to put your hand under the hot water at full heat for probably 5 seconds. And if you can't do that, if it's so hot you can't put your hand, it's too hot, and then you run the risk of burning somebody or your kids. But that is a part of maximizing the efficiency on this. They do have a vacation mode on it. This is something a lot of people don't think about when they leave. Or they're gone for a while. They don't think about turning the water heater down. But it's just sitting there holding, your 130-degree water, whatever you have it set up. And so it has this. It's really convenient. It's all in the settings, and just click it on vacation mode. It defaults to 7 days, or you can say, how many days. And then it turns it on the day before you get back. So as soon as you come back, it's all good again.
Suppose they have an app for that too.
They do. Yeah, most of these have apps. Yeah.
So if you forget, you get to Cancun, get on the app and you can set it.
Absolutely. And, we're gonna see, we talk a lot about smart homes and stuff, and this is something that we're seeing more and more of is Wi-Fi. So the house I'm working on now, we don't have the budget to make a smart home. But we have Wi-Fi in the sprinklers, Wi-Fi in the thermostat. He's got cameras, like a Ring type system. And he likes accessing everything from his phone. And so this would just be another part of that. So I think we're going to see a lot more development in that. Lighting, it's just become so cost effective, to build it into the lighting to the outlets. I have several people that run these types of systems that, the garage door will let you know that if it's open, if it's left open, or you can set a timer on it. It'll tell it to turn off. We just set something else. Oh, he wanted a keypad. He's locked himself out of his house multiple times, and because I'm working on it, I have keys, and so he has to drive all the way out my house to get the key. So I put a keypad door lock system on it, and the door lock, it actually, you can set it to where after you own the house, 90 seconds later, it just locks automatically. And of course, on the inside, it's manual unlock, but on the outside, you can just key it to open it. So he doesn't even carry the keys anymore, and he doesn't worry about locking it because he knows it's going to lock by itself. So it's kind of cool, and I think we'll see, more of this stuff come together, so you don't have a string of apps. I have 2 systems that I'm working with right now, and one system could handle virtually everything like that. So you're not having to pull up an app for each individual appliance or camera. So this was kind of a surprise. It's like, well, how good are these things? And again, this is an energy guide. It's for comparison purposes. This is a national sticker. If you read these, this is nationwide. So it's a very average. It would be hard to compute this to here. There may be a way to do it to adjust it per climate, but again, your interior location and everything has an effect. But if you put these systems side by side, one of them's going to use about 20% of the energy. So the potential, there's a ton of potential there. And if you're looking at, so I just doing some quick math in my head, please don't quote me on any of this. Just trying to help with the thinking through it. If I'm paying $200 a year to heat my hot water with gas, and I said there was about a 2.2, 2.4 cost difference between electric. So if I multiply my 200 by 2.4, I'm at almost 500 to go electric, right? Very close to what this is saying, right? And so even though I'm paying, 220, 240 in gas, this is still a very competitive, I don't think I would change to go to this one, but I may change to go to this one. And we don't like to offend any of the utilities or anything. We have to be cautious about fuel preference and stuff. But if you are doing a solar system or you're in an all electric area, this becomes an obvious consideration. The biggest deterrent is again, I think there's several. I'll cover the kind of our uptake obstacles there in a minute, but this is pretty obvious. So cost. These 2 water heaters, just so you understand the comparison, these are both 50 gallons. So these are, this is 50 gallon normal electric, 50 gallon hybrid heat pump. And then this is the cost on it. So this is at Grover's, which is kind of a big do-it-yourself store here in Boise. And they are available. Year round, doesn't seem to be any supply issues. And they have 3 sizes here, and you can see that the size, changes, going from a 50 to an 80. That's up pretty quick. So sizing is part of the driving cost. I talked with Gensco, which is a local wholesaler for a lot of HVAC companies. They had 2 brands available, and they don't give you wholesale because it depends on your rating as a contractor. But the retail on their unit was $3,500. So you can see there's some price fluctuation. And then I didn't take pictures of it, but if any of the people attending today are interested in this, Sanden, 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 yes, Sanden. They make a kind of a different setup that uses just an indoor storage tank, and the unit sits outside like a typical heat pump on a house. So you have an outdoor compressor and refrigerant lines that run into the indoor unit. Quite a bit more expensive, but a little bit of a different principle there. With that type of a system, you could use a hot water system for radiant heat in the floor. You can use an air coil system for actually heating air, where you're running it through a heat exchanger to warm a space. Potentially, you could use it for some limited snow melt. There's a lot of variations there. And so there is a way to tie this technology into a broader spectrum besides just heating the hot water for hot water. So I wanted to kind of look at those. The pricing on those was, there were too many variables to really get a good pricing on it, but their standard, this type of water heater was $3,500 retail. Oh, this is something else that I do, and I thought this would be a good example of this space, actually thinking through and designing the space. And so this is my house. I have, we didn't do a lot of intentional design, but we did think about the location and the orientation and stuff to try to make this house super efficient. And so this is last week, and there's a date on there. This was just a few days ago. Inside the house, I wanted to use this to point out a couple of things. One, you can see that the house, the temperature stability is really narrow. It doesn't vary more than 0.5 degree at night. And so this is during the day. This is the setback at night. And then about 9:30, the sun comes up, starts warming the house up, and from 10 o'clock to about 6:15, the furnace never comes on again. And it's only getting up to 33 degrees outside. So this is free heat. This is all day long, over 8 hours a day, but I'm not heating the house. Furnace is not coming on. And this can get up as high as 78, 79. And so when it's that warm, I would love to be able to put some of that heat somewhere else. So this is a particularly cold day, but most of the winter we'll have 8 to 10 hours a day where the furnace is not running. And so it's just an example of potential and thinking not just of the appliance itself, but kind of thinking through the design and using nature as part of passively assisting the system. So if you could duplicate this scenario in a utility space or in portion of the garage that could be closed off, if there was a way to integrate some of this and or just borrow the air from this warm space, because this would actually tie in pretty well with most people's use. They're going to use, a lot of hot water in the morning and again at night. So if you are watching this, you would know that, you've been able to use this free heat all day long. This would be the time to do the laundry and stuff like that. So kind of using again, using little bits of inexpensive technology to kind of assist with the rest of it. And if somebody is thinking about, putting one of these in their home, that might not be a bad idea. It's just to go set a sensor in the location. It's like, what do we have, and is it going to be affected by a 3-degree temperature drop, or is it going to be? So there's a way to kind of, I'm trying to, stir the design part of things a little bit. So market uptake, these are not new. I did some work on it early on. It was pretty slow coming on in Idaho, and again, I think it has to do with our, we're typically one of the top 3 lowest utility rates in the country, and that's a good thing. I'm not complaining. But it makes the upfront cost hard to recover, and so we don't know if that's going to change. What I really wanted to do was I wanted to help people understand the installation. This is not complicated. This isn't anything more different than putting in a regular one, other than you have to put a condensate drain on it. The one thing I didn't cover today, because I just didn't want to add all that in there, is it is a pump. It makes noise, and so the location, we have to think about that. Do we need to maybe sound deaden around a little bit? There are definitely things to mitigate the noise, but I don't think, Damon, if we put this next to the furnace in your house, you probably would be okay with it. So there are things to consider, and noise would be one of them. My understanding is they're fairly quiet. They're not like your outside compressor for your air conditioner, but they do make noise. I've always wondered about the sleep number beds, because they use a compressor, and they put it underneath the bed, and it's like, that thing's coming on and off. So I never bought one or tested one, but I was always curious. It's like, wouldn't that wake you up?
Hey, Jerry.
Yes, sir.
We have a couple questions online.
Okay.
The first one is from Lindsay Love. It is it still worthwhile to install a heat pump water heater if it is a small home with no garage?
I think ideally, I mentioned that everything in the Treasure Valley being in garages more as a statement than a recommended location. So I think if you could put it in the home and locate it in an area that maybe was separated by the bedrooms, or that you were able to do a little sound deadening on, I think it'd be fine. The warmer where you put this, the more efficient it's going to operate. So I don't see any reason why you wouldn't want it inside if that was your only option.
Okay. And then Chad says, hard water causes calcium to build up inside water heaters and on the heat elements, eventually causing them to corrode and short out. It seems like it is difficult to clean out built up calcium once it's there. How do you keep the tubing inside a heat pump water heater from gathering calcium around the tubing and lessening its effectiveness?
So on almost all electric water heaters, everyone that I've ever worked on, if you look at the top of it, it looks like a plug. There you have your hot intake, your cold intake, and then there's just like a bolt on the top of it. If you unscrew that, it's called a digester rod, and that digester rod prevents that calcium buildup. That's why it's there. It stops that ionization from happening in the water. It gives it something for everything to stick to. They use the same thing on sailboats and ocean going boats that are in salt water. They have strips under the boat that attracts all of that, so it's not sticking to the hull and the shafts and stuff. So it's not complicated. It's just a mineral part of it. Obviously, if we go back to the picture with all the coils and stuff in there, keeping it clean is going to be a necessity, but I would be less concerned about the calcium and more concerned about flushing it on a fairly regular basis. And so a homeowner, you could set up a schedule, a tenant arrangement, or multi-housing something. You would have to have that on some type of a maintenance schedule to get the life out of it.
Okay, that was all the questions.
So back to market uptake, there are grants available at different utilities. I did not check with Idaho Power to see if there was anything in this area, but I know that that's been a big part of the marketing previously. And it appears that they're still offering these in Washington and Oregon. And so I don't know, I honestly don't know what the status is here in the Treasure Valley.
There's a website run by NIA called Hot Water Solutions.
Okay.
And if you just put in your zip code, it will show you all the utility rebates that are currently available.
Okay.
I know, pretty sure Intermountain Gas has a rebate for hybrid water heaters.
Okay. Dylan, can you hear that okay?
Yeah.
No?
I'm sorry, what?
Did you hear Damon's comments?
No.
Okay. So there is a website on NIA's website. It's called Hot Water Solutions, and you can punch your zip code into that, and it will tell you what rebates are available in that area. So availability doesn't seem to be a problem. They don't stock it. Again, I'm not trying to be negative, but just trying to give people accurate information. Grover said the salesman I talked to, who's there almost every time I go in there, he said that they sell about 4 of these a year. So not a huge uptake from there. Asking if they had any problems or customer complaints, he said nothing that he was aware of. So whoever's buying them is obviously happy with them. Gensco, they have, when you walk in there, they have a whole desk of salespeople there. We just kind of asked around in the group, and they said the sales were really limited. So the demand was quite limited. So, but they were available, and Gensco Grover's has them in stock. You can walk in there and grab one. Gensco has them; they can get them the next day. So there isn't an availability problem. And which brings us to the last part, which is the marketing. And in order for somebody to move a product to general market, they have to do their part. And so we see the same thing with widespread adoption of mini splits and stuff. Super efficient, but nobody's running commercials on TV. Nobody's trying to get it to out to the consumers and stuff. And so we come back to the design side of it, talking to you guys and saying it's here, it's available, they've got the bugs worked out of it, they work. Consider this as part of your design. So for people that are really trying to build something super efficient or semi off grid, this is a good way to get there. Any more questions?
Chat. I also wanted to mention also on another NIA website, there's betterbrick.com, and they've got a number of case studies for the Northwest on another question on it. See if I can plug that website.
So the question is from Rebecca. Can you discuss incentives, Idaho Power Company and federal?
So Damon is pulling up another site. There's another site that you can look at. It's called Better Bricks. And they have some incentive guidelines in there.
So website for utility incentives. Might actually bounce this up to Moscow. But I don't know if that covers, federal incentives. But there's also the Better Bricks.
So I just went through the new federal tax rebate program for new homes last week. And so I haven't had a chance to dig into that very deeply. But we were hoping to have that information out to contractors and stuff quicker. So, you know, all of the homes and the products that are listed were available back to January of 2023, but we're just now catching up with the education component of it. So I don't know. It's my short answer. I will look in that a little more in depth, but it's
Would there be any benefit, or is there any natural gas heat pump ones that have the natural gas for the backup instead of electric?
so like a dual fuel system. Yeah, I think you'd have to. So that was the interplay with the Sandin system, because you can preheat the water before it comes to the water heater. And so if you have the room, you know, you could run that outdoor unit on heat pump only and heat a large amount of hot water and then use that to preheat, you know, another water heater. And that would be, you'd have a lot of capacity, and you don't need to heat it to the temperature that you're going to ultimately use. So you could heat, you know, 100 gallons up to 100 or 110 degrees and have it sitting there instead of putting 50-degree groundwater into it, you know, which would make this one super efficient. So there is a way to integrate them, but I'm not aware of any product that where a gas has the heat exchanger in it. I think you'd have to design that. I'm not aware of anything that's listed that way. We do have dual fuel heating systems, you know, that's pretty common for people to have gas furnace, you know, electric AC. So it's not a reach, but I'm just not aware of it.
Okay.
Any other questions? Presentation just for a second. Just want to throw in a pitch for the upcoming training. I know I appreciate all of you guys that have attended these classes all year, but if you missed any of them, here is what's going to be happening in the next couple of weeks. We'll be going back over everything, give a chance for anybody that wasn't aware, you know, to attend again. And then this invite is being sent out to a larger group. So, you know, but hopefully I'm not interfering with anybody's Christmas schedule. I know it's a tough time of year, but we did want to offer this again. So for next 2 weeks on Tuesdays, these are 1-hour classes with a 15-minute break between them.
And are
so
these here?
they'll be right here. And they're free. So,
Heck yeah.
so we'll see you next week. Thanks again for your time today. Appreciate it.
Thanks, Jerry.